In this video, we're going to talk about what StatefulSet is in Kubernetes and what purpose it has. So what is StatefulSet? It's a Kubernetes component that is used specifically for stateful applications. So in order to understand that, first you need to understand what a stateful application is. Examples of stateful applications are all databases like MySQL, Elasticsearch, MongoDB, etc., or any application that stores data to keep track of its state. In other words, these are applications that track state by saving that information in some storage. Stateless applications, on the other hand, do not keep records of previous interaction, and each request or interaction is handled as a completely new, isolated interaction, based entirely on the information that comes with it. And sometimes stateless applications connect to the stateful application to forward those requests. So imagine a simple setup of a Node.js application that is connected to MongoDB database. When a request comes in to the Node.js application, it doesn't depend on any previous data to handle this incoming request. It can handle it based on the payload in the request itself. Now, a typical such request will additionally need to update some data in the database or query the data. That's where MongoDB comes in. So when Node.js forwards that request to MongoDB, MongoDB will update the data based on its previous state or query the data from its storage. So for each request, it needs to handle data and obviously always depends on the most up-to-date data or state to be available. While Node.js is just a pass-through for data updates or queries, and it just processes code. Now, because of this difference between stateful and stateless applications, they're both deployed in different ways using different components in Kubernetes. Stateless applications are deployed using deployment component, where deployment is an abstraction of pods and allows you to replicate that application, meaning run 2, 5, 10 identical pods of the same stateless application in the cluster. So while stateless applications are deployed using deployment, stateful applications in Kubernetes are deployed using StatefulSet components. And just like deployment, StatefulSet makes it possible to replicate the stateful app pods or to run multiple replicas of it. In other words, they both manage pods that are based on an identical container specification. And you can also configure storage with both of them equally in the same way. So if both manage the replication of pods and also configuration of data persistence in the same way, the question is what a lot of people ask and are also often confused about: what is the difference between those two components? Why we use different ones for each type of application? So in the next section, we're going to talk about the differences. Now, replicating stateful application is more difficult and has a couple of requirements that stateless applications do not have. So let's look at this first with the example of a MySQL database. Let's say you have one MySQL database pod that handles requests from a Java application, which is deployed using a deployment component. And let's say you scale the Java application to 3 pods so they can handle more client requests. In parallel, you want to scale MySQL app so it can handle more Java requests as well. Scaling your Java application here is pretty straightforward. Java applications' replica pods will be identical and interchangeable. So you can scale it using a deployment pretty easily. Deployment will create the pods in any order, in any random order. They will get random hashes at the end of the pod name. They will get one service that load balances to any one of the replica pods for any request. And also when you delete them, they get deleted in a random order or at the same time, right? Or when you scale them down from 3 to 2 replicas, for example, one random replica pod gets chosen to be deleted. So no complications there. On the other hand, MySQL pod replicas cannot be created and deleted at the same time in any order, and they can't be randomly addressed. And the reason for that is because the replica pods are not identical. In fact, they each have their own additional identity on top of the common blueprint of the pod that they get created from. And giving each pod its own required individual identity is actually what StatefulSet does, different from deployment. It maintains a sticky identity for each of its pods. And as I said, these pods are created from the same specification, but they're not interchangeable. Each has a persistent identifier that it maintains across any rescheduling. So meaning when pod dies and it gets replaced by a new pod, it keeps that identity. So the question you may be asking now is, why do these pods need their own identities? Why they can't be interchangeable just like with deployment? So why is that? And this is a concept that you need to understand about scaling database applications in general. When you start with a single MySQL pod, it will be used for both reading and writing data. But when you add a second one, it cannot act the same way. Because if you allow two independent instances of MySQL to change the same data, you will end up with data inconsistency. So instead, there is a mechanism that decides that only one pod is allowed to write or change the data which is shared, reading at the same time by multiple pods, MySQL instances from the same data is completely fine. And the pod that is allowed to update the data is called the main, and the others are called replicas. So this is the first thing that differentiates these pods from each other. So not all pods are identical, but there is a main pod and there are the replica pods. And there is also a difference between those replica pods in terms of storage, which is the next point. So the thing is that these pods do not have access to the same physical storage. Even though they use the same data, they're not using the same physical storage of the data. They each have their own replicas of the storage that each one of them can access for itself. And this means that each pod replica at any time must have the same data as the other ones. And in order to achieve that, they have to continuously synchronize their data. And since the main is the only one allowed to change the data, and the replicas need to take care of their own data storage, obviously the replicas must know about each such change so they can update their own data storage to be up to date for the next query request. And there is a mechanism in such clustered database setups that allows for continuous data synchronization. The main pod changes the data, and all replicas update their own data storage to keep in sync and to make sure that each pod has the same state. Now let's say you have one main and two replica pods of MySQL. What happens when a new pod joins that existing setup? Because now that new pod also needs to create its own storage and then take care of synchronizing it. What happens is that it first clones the data from the previous pod, not just any pod in the setup, but always from the previous pod. And once it has the up-to-date data cloned, it starts continuous synchronization as well to listen for any updates by master pod. And this also means, and I want to point this out since it's a pretty interesting point, it means that you can actually have a temporary storage for a stateful application and not persist the data at all, since the data gets replicated between the pods. So theoretically, it is possible to just rely on data replication between the pods. But this will also mean that the whole data will be lost when all the pods die. So for example, if StatefulSet gets deleted or the cluster crashes or all the nodes where these pod replicas are running crash and every pod dies at the same time, the data will be gone. And therefore, it's still a best practice to use data persistence for stateful applications if losing the data will be unacceptable, which is the case in most database applications. And with persistent storage, data will survive even if all the pods of the stateful set die. Or even if you delete the complete stateful set component and all the pods get wiped out as well, the persistent storage and the data will still remain. Because persistent volume lifecycle isn't connected or isn't tied to a lifecycle of other components like deployment or stateful set. And the way to do this is configuring persistent volumes for your stateful set. And since each pod has its own data storage, meaning it's their own persistent volume that is then backed up by its own physical storage, which includes the synchronized data or the replicated database data, but also the state of the pod. So each pod has its own state, which has information about whether it's a main pod or a replica or other individual characteristics. And all of this gets stored in the pod's own storage. And that means that when a pod dies and gets replaced, the persistent pod identifiers make sure that the storage volume gets reattached to the replacement pod. As I said, because that storage has the state of the pod in addition to that replicated data. I mean, it can clone the data again, that will be no problem, but it shouldn't lose its state or identity state, so to say. And for this reattachment to work, it's important to use a remote storage, because if the pod gets rescheduled from one node to another node, the previous storage must be available on the other node as well. And you cannot do that using local volume storage because they are usually tied to a specific node. And the last difference between deployment and StatefulSet is something that I mentioned before, is the pod identifier, meaning that every pod has its own identifier. So unlike deployment, where pods get random hashes at the end, StatefulSet pods get fixed ordered names, which is made up of the StatefulSet name and an ordinal. It starts from 0, and each additional pod will get the next numeral. So if you create a StatefulSet called MySQL with 3 replicas, you'll have pods with names MySQL 0, 1, and 2. The first one is the main, and then come the replicas in the order of startup. An important note here is that the StatefulSet will not create the next pod in the replica if the previous one is not already up and running. If the first pod creation failed, or if it was pending, the next one won't get created at all. It would just wait. And the same order is held in deletion, but in reversed order. So for example, if you deleted the StatefulSet, or if you scaled it down to 1, for example, from 3, the deletion will start from the last pod. So MySQL 2 will get deleted first. It will wait until that pod is successfully deleted, and then it will delete MySQL 1, and then it will delete MySQL 0. And again, all these mechanisms are in place in order to protect the data and the state that the stateful application depends on. In addition to these fixed predictable names, each pod in a StatefulSet gets its own DNS endpoint from a service. So there's a service name for the stateful application, just like for deployment, for example, that will address any replica pod. And plus, in addition to that, there is individual DNS name for each pod, which deployment pods do not have. The individual DNS names are made up of pod name and the manage or the governing service name, which is basically a service name that you define inside the StatefulSet. So these two characteristics, meaning having a predictable or fixed name as well as its fixed individual DNS name, means that when pod restarts, the IP address will change, but the name and endpoint will stay the same. That's why I said pods get sticky identities, so it gets stuck to it even between the restarts. And the sticky identity makes sure that each replica pod can retain its state and its role even when it dies and gets recreated. And finally, I want to mention an important point here. As you see, replicating stateful apps like databases with its persistent storage requires a complex mechanism. And Kubernetes helps you and supports you to set this whole thing up, but you still need to do a lot by yourself, where Kubernetes doesn't actually help you or doesn't provide you out-of-the-box solutions. For example, you need to configure the cloning and data synchronization inside the StatefulSet and also make the remote storage available, as well as take care of managing and backing it up. All of this you have to do yourself. And the reason is that stateful applications are not a perfect candidate for containerized environments. In fact, Docker, Kubernetes, and generally containerization is perfectly fitting for stateless applications that do not have any state and data dependency and only process code, so scaling and replicating them in containers is super easy.